Question 5 from the 2014 M2 paper. Okay, I've started off and I've drawn the diagram down, as you can see here, just marking on all the key information. Now I'm going to solve this problem using velocities, although I think it could equally be solved using speeds, but this is my way of solving the problem. Okay, first of all, if we use minus E equals V2 minus V1 over U2 minus U1, and let U2 and V2 be the velocity of the wall, which of course will be 0 throughout, we'll end up with this relationship. Minus E equals 0 minus V1 over 0 minus U1, which can be simplified to give you V1 equals minus E times by U1. And in fact, if you have a look through your notes, then you will have that result. And that's in terms of velocities. If you're working in terms of speed, you'd simply say that V equals EU. In other words, the speed after a collision with a wall would be E times by the speed of the object before it had the collision with the wall. Okay, so using that, I can now say that V1 is equal to minus 2/3 U, if I'm talking about velocities, and I'm just going to use the formula for impulse, I equals M parenthesis V minus U. Okay, now the first thing I'm going to do is actually write the impulse in that's been given, but I'm going to write it as minus lambda times mu. And the reason for that is the problem talks about the impulse that the object receives from the wall, and if you think about it, the impulse that it receives from the wall is actually in the negative direction, given that I've chosen working to the right as the positive direction. And now I'll just put all the other information in, which gives me this result, and I'll cancel the m's out, and that takes me to this line here, and the last bit of simplification then gives me that lambda is equal to 5/3. Now I prefer to work, as I've said before, with velocities simply because as I work through the problem from start to finish, at no point in time really do I have to stop and think. Everything takes care of itself with regards to signs and so on. Okay, now for the next part, in fact, I'm going to use speeds, as you'll see. So if I start out with just rearranging speed as distance over time to give me that time is equal to distance over speed, I can then say, well, for the first part of the journey, the distance travelled is 1 metre, and it does so at a speed of u, so that time, t1 I've called it, would equal 1 over u. For the next part of the journey, the object is going to travel 2 metres to the other wall, and we had that the velocity was minus 2u over 3, so I'm just saying the speed is 2u over 3, and again just popping it into time is distance over speed, it will give me this result here that simplifies to 3 over u. I've now got to consider this collision with the wall, so I've just flipped back to velocities for a minute and just said minus 2u over 3, and so after the collision with the wall, using the idea of minus e times by the speed of approach, so to speak, hopefully you should see that I end up with a speed of 4u over 9, or indeed a velocity of 4u over 9, as it's now moving in the positive direction, and it has to move 1 metre at a speed of 4u over 9, which gives me that t3 would be 1 over 4u over 9, which of course is 9 over 4u. So the total time would be t1 plus t2 plus t3, and we're told that's equal to 3. So if we now substitute all of this in and simplify a little, we'll see that t1 plus t2 plus t3 equals 25 over 4u. That's equal to 3, so one more step will give us that u is equal to 25 over 12. And that's the problem solved.